All right, students, today we're going to learn about maps. And it's just a flat representation of the areas on the Earth. It's a lot easier to carry maps around than to try to be carrying around a globe the size of a basketball, so travelers used a map.
Let's talk legends, y'all. I am the king.
A map is a model, yo, of the Earth's surface.
Skating in between.
A representation of the Earth's surface.
The known and the unknown.
A map is a model of the Earth's surface, yo.
Garden path to the compass world.
True north is the geographic North Pole. It doesn't line up with the magnetic North Pole. Adjusted on a compass with a compensation. The difference is called magnetic declination.
The round Earth turns around on its axis.
A map is a model, yo, of the Earth's surface.
North Pole, South Pole, the ends of the axis.
A map is a model, yo, of the Earth's surface.
Let's talk legends, y'all. Down the garden path to the compass world. I am the king.
Lines of latitude parallel the equator and reach the poles 90 degrees later. Longitude lines go up and down the prime meridian. Time begins again in Greenwich, England. Meantime, the 0-degree
The
line.
round Earth turns around on its axis.
A map is a model, yo, of the Earth's surface.
North Pole, South Pole, the ends of the axis.
A map is a model, yo, of the Earth's surface.
North, South, East, West, and points on the compass.
A map is a model, yo, of the Earth's surface. A representation of the Earth's surface. A map is a model of the Earth's surface, yo.
The round Earth turns around on its axis.
A map is a model, yo, of the Earth's surface.
North Pole, South Pole, the ends of the axis.
A map is a model, yo, of the Earth's surface.
North, South, East, West, and points on the compass.
A map is a model, yo, of the Earth's surface. A representation of the Earth's surface. A map is a model of the Earth's surface, yo.
That was me, baby.
A map is a model, yo, of the Earth's surface.
Who's trying to say that, baby?
A map is a model, yo, of the Earth's surface.
If you can scale around between.
A map is a model, yo, of the Earth's surface. A representation of the Earth's surface. A map is a model of the Earth's surface, yo.
Things on this map. For example, since the Earth is round, a globe is actually more accurate. When you flatten it out, some places become bigger, but as I said, it's harder to carry, and because of this, paper has become much more popular. Digital maps have started changing this slightly. We also have cardinal directions, and these are north, south, east, and west, followed by intermediate directions, which would be your northeast, southeast, southwest, and northwest.
Northeast, south, and west, never reach all to one. Northeast, south, and west, never reach all to watermelon. Northeast, south, and west, never reach soggy worm. Northeast, south, and west, never reach all to watermelon. Northeast usually up on the map, like the 12 o'clock is at bedtime. Then we direction is it in? Your what? Nose? Your compass? Nose? Your compass rose. What direction is it in? Your what? Nose? Your compass? Nose? Your compass rose. Northeast, south, and west. Never read soggy words. Northeast, south, and west. Never read soggy watermelon. Northeast, south, and west. Northeast, south, and west. Northeast, south, and west. Northeast, south, and west. Northeast, south, west. Never eat salty watermelon.
All right, we're also going to talk about maps. The first type is a physical map. This is a map that shows you the physical characteristics of the place or the area that you're looking at. For example, mountain ranges would be darker red, whereas lower areas would be green. Now, this shows your physical, the geographic.
Did you know that there are many different types of maps? Some are really big and show things like the planet Jupiter, while others are small enough to only show a single city block. We can learn all sorts of things from maps. Some maps are topographical, which means they show us what areas of the world are like, how tall the mountains are, where there are rivers, and more. Other maps are political and show where the borders of different nations and cities are. There are also maps that lead you from place to place by showing you where the roads lead. The right map will open the world for you. You might be wondering what's different from a map and a photograph. A map must be drawn by someone called a cartographer. They decide what type of map it's going to be, where it's going to show, and how it looks. It's a really important job to have, and cartography has been around for thousands of years. How many different types of maps have you seen?
The types of maps would also have political map. This would be basically showing a territory or a country's borders. Map would be a choropleth map, and as you can see here, the choropleth is a thematic map that shows areas that are colored or patterned based on statistical data. So what you have on this data, you see that the colors represent different densities. So whether it's less than 0.25, which would be yellow, all the way up to greater than 0.6, which would be a maroon color. Cartographers, which would be map makers, they also add a compass. A compass is very important for you guys to find because it makes the map easier to understand. Now, you also have the compass rose, and it shows the orientation and direction of the maps. You also have a scale. The scale shows you how, if you measure this area on a map, that's how big it can be. The compass is going to tell you which direction is north. Just because a map may be right side up doesn't necessarily mean the map makers have to have north pointing up. The scale helps the viewer convert the map into real life.
Welcome to another video on Geography Skills by the Wimbledon channel. Today we're going to be looking at scale. First we'll ask, what is scale and why do we need it? Well, if we didn't have scale, then our maps would be absolutely massive. And so we shrink them all down to a more manageable size. But as our childhoods can attest to, shrinking things down to size can be a little difficult. And so scale helps keep things in proportion. And usually looks something like this. 1 centimetre on the map equals lots and lots and lots of centimetres in real life. There are 3 ways in which scale is written on a map. As a statement, as a line scale, and as a representative fraction or ratio. The statement is pretty self-explanatory. The scale is simply written as a statement. So 1 centimetre to 1 kilometre, or perhaps 1 centimetre equals 1 kilometre. Line scales are a bar at the bottom of the map that's marked at even intervals. They usually look something like this. The bar is to scale, so if you measure a centimetre on the bar, it equals whatever the scale says to kilometres. So you'd measure the distance on your map, then go down to the scale and measure that same distance and see how many kilometres it is. Lastly, representative fractions or ratio scales. You might have seen these in maths, where you've got the number on the left, then a colon, then the number on the right. Here it's saying the number on the left is 1 centimetre and the number on the right is equal to 250,000 centimetres. Basically, the higher the number on the right, the larger the area that it's dealing with and the less detail you'll see. So a 1 to 1,000 ratio would be a really detailed map, but only cover a small area. Whereas a 1 to 250,000 scale map would be much less detailed but cover a huge area, like we're talking a state here. The big problem with representative fractions is you're going to have to use maths. So be really careful, get your calculator out and make sure you know exactly how many centimetres in a metre, how many centimetres in a kilometre, etc. So that's a brief look at scale. If you have any questions, don't forget to comment below. And if you want more of these videos, click subscribe.
We have latitude and longitude. These help us to accurately locate areas on the Earth. These are invisible lines, they're not actually there. And their latitude and longitude, they crisscross pretty much like a grid.
Imagine that you're flying in a plane. Beautiful skies, amazing views. But how do you know where to go? There aren't any signs floating in the air, right? So how do pilots know where to land their planes? Would you like to find out?
I would.
In this lab, we're going to be learning about the invisible lines that help us navigate the world, longitude and latitude. This is a compass. It can tell you which direction you are traveling, north, east, south, west. A good way to remember is to remember the saying, never eat soggy waffles. But just knowing which direction you're going isn't enough to pinpoint a specific place. Look here. Let's say we're here and we want to go to that spot right there. We know we're going east, but how far east? Where do I stop? Is it southeast, northeast? Now imagine you were up in the air and you wanted to find this point. How would you be able to see it?
Yeah, I'm not seeing any dots up here.
That's right. Well, we can help them by drawing some lines to really find that point. Can you picture these lines running all around the Earth? These are called lines of longitude, and they run north and south. But that's not what they're there for.
Hi, Dr. Nagler. It took me all night, but I finally finished hand-making that globe you wanted.
Excellent. Looks good, especially the lines. What do you think these longitude lines tell us? Well, imagine if you could cut through one. Why imagine? Let's do it!
You cut through my globe.
Of course I did, and it cut very nicely. You see, longitude lines run north to south, but they separate east and west. To help identify these lines, we number them. This line is 0 degrees longitude, also known as the prime meridian. Degrees in this case isn't temperature, it's a unit of measure that we tell how far away from the center we are. So we start with 0 degrees and we move away from the center. So this line would be 10 degrees and this one would be 20 degrees and so on. And also notice on the other side of 0, the same thing happens, 10 degrees and 20 degrees. And the way we label these is which side of 0 is east and west. And you'll notice that this point is 10 degrees east, and this one is 10 degrees west. So here is our point at 30 degrees east. But is that enough to land our plane? What do you think?
Okay, I'm flying on that longitude, but I don't see the runway. That's not enough information.
That's right. You need to know where on the line our point is. Is it down here? Up here? We need lines going the other way to intersect our lines of longitude. So the longitude lines separate east and west. What do you think these lines will do?
Okay, Dr. Nagler, I was able to make one more globe. Please be careful with this one.
Of course I will. I have safety glasses on.
I need a new job.
You see, I cut laterally to create latitude lines. These lines go from east to west, but they separate north and south. These two halves are called hemispheres, which means half a sphere or half a globe, north and south. Just like the longitude lines, latitude lines are numbered beginning with 0 degrees in the center. This is called the equator. Let's label these lines as we did before, starting with 0 degrees equator and going 10 degrees north and 10 degrees south, away from 0. Now, let's see where our point is. The latitude lines have intersected our longitude lines right at our point. Now we have two lines that cross, and X marks the spot. Our point is 20 degrees north and 30 degrees east. These two numbers are called coordinates. Will that be enough to land the plane?
Okay, I see it. I see the runway.
So did you learn anything useful today?
Yes, I did. I learned that it takes two coordinates to find yourself on the globe: longitude and latitude.
That's right. Latitude and longitude are invisible lines used for navigation that intersect at specific points. What else did we learn?
I learned not to give you the keys to the chainsaw.
That's not all. Didn't we learn what the two halves of the globe are called?
Hemispheres.
And what does hemisphere mean?
Half of a globe.
That's right. And remember, the point where the hemispheres meet is labeled 0 degrees, and we start numbering there in both directions. Now that we've learned how longitude and latitude work, you're going to find some points on the globe yourself.
Are the ones that go around the Earth. They are called parallels. And you can remember these because they begin at the equator. And the way I always remember it is fat and lat. Lines of latitude go around the belly of the Earth and therefore the fatness of the Earth. So fat and lat, those are the ones that go around the Earth. So they spread equal distance between themselves all the way up to the North and South poles. The equator divides the Earth in half, separating it into northern and southern. Now you have the equator at 0 degrees. The North Pole would be at 90 degrees. All right? And then you have the South Pole at 90 degrees. Then the South Pole, fill those in. The latitude and longitude lines are divided into these degrees. Each degree is broken down into 60 minutes. So if you wanted to get more precise than just that degree, you would start adding on minutes. Each minute is further broken down into 60 seconds. So the approximate latitude equals the approximate amount of 101 feet. All right, so I know that's a whole lot. So let's just think about it this way. The latitude of Paris is 48.8566 degrees north, and its longitude is 0.3522. Or you could say 85 minutes, 66 seconds. The lines of longitude are called meridians, and longitude, they go around the long ways of the Earth. Longitude lines begin at the prime meridian. They spread equal distance around the east and west, to the international date line. The prime meridian and the international date line divide the Earth into east and west hemispheres. So the prime meridian is at 0. At 30, you have the international date line at 180. Then you have the international date line at 180. A second of longitude is approximately 80 feet. GPS uses latitude and longitude to provide coordinates.
Oof. I've literally had the longest day ever. Hello, quite stressed. Maddie, really long day? Maddie? Hello? Hello? Sorry, what were you saying? Watermelon? No, thank you, I don't want a watermelon. I was just saying that I had to get up at 3 a.m. to call my boss in LA, and that was just the start of it. And then I'm sorry, where have you even been? Samoa and Tonga. I'm basically a time traveller. Care to explain? Sure. So we've all had days that feel like the longest day ever, but that got me thinking, how could I literally have the longest day ever? What would I have to do? And then that got me onto the very confusing subject of global time zones, the international date line, and time travel. Imagine this watermelon is our planet. It's a rough rotating sphere, and it rotates an entire 360 degrees in 24 hours, which is the time it takes from sunrise to sunrise. Knowing this, we can work out how far the world travels in 1 hour. So if we take our 360 degree rotation and divide it by 24, we get 15. So every single hour, the world rotates 15 degrees. And we mark this using vertical lines of longitude, also known as meridians. And quite handily, this watermelon here has veins which will represent those quite nicely. 24 vertical meridians, each one marking 15 degrees and 1 hour's worth of time. It's all very well having 24 1-hour zones on our planet, but we need them to start somewhere. And this is where the Greenwich Meridian comes in. It marks 0 degrees, the point where time starts, and it runs through Greenwich in London. The Greenwich Meridian, marked out by my beautiful red sticky dots, was chosen as the starting point of time, 0 degrees, because at the time in 1884, 72% of the world's commerce depended on sea charts, which used Greenwich as their prime meridian. So this is where it all begins. It's midday GMT, Greenwich Meridian time. The sun is directly overhead. However, it was midday 1 hour previously, +1, that's to the east of our line. So if I just rotate the Earth backwards 15 degrees, we can see here we find midday on +1. I then rotate to the east 15 degrees and continue to our -1 line. We find it's not midday till 1 hour later, and this is why we have plus lines of longitude and minus lines of longitude as the Earth continues to rotate in an easterly direction. As long as we know the location of two places on Earth, we can work out the exact time difference between them. LA is 120 degrees away from the UK. If I divide 120 by 15, that's 15 degrees per hour, I get 8. That's 8 hours. So the UK is 8 hours ahead of LA. -1, 2, 3, 4, 5, 6, 7, 8. Now, Stressed Maddie called it 3 a.m. If we subtract 8 hours, it was only 7 p.m. in LA. The Greenwich Meridian marks time 0 and enables us to add or subtract hours so we can work out time differences across the globe. But we need a way of defining exactly when a new day starts. After all, you can't continue to fly around the world in an easterly direction just subtracting hours as you go, because you would lose days, and that's time travel, which is impossible. Yet, as there are 24 hours in a day, it makes sense for a new date to start 12 hours or 180 degrees away from the meridian line. So if I subtract 12 hours, we find ourselves at the international date line. Now, here we have from 12 p.m. till 12 midnight on a Monday. The moment we cross over, we find ourselves at 1 a.m. on our Tuesday. Tuesday then starts to grow, slowly eating up Monday as the Earth rotates, until eventually we get to Tuesday, 12 p.m. Now there's only so much I can show you with a watermelon, so I'll leave some video with better graphics down in the doobly-doo. So the date immediately to the left-hand side of the international date line will always be 1 day ahead of the date immediately to the right-hand side of the international date line. In fact, if you were to go to the North Pole, you could walk around in circles crossing from day to day. Conveniently, the international date line largely lies in the Pacific Ocean. However, you can see it's not quite straight, as it's been moved slightly over the years to accommodate the needs of various countries. As I'm sure you can imagine, it can be pretty frustrating for two countries to do business with each other when they're only a mere few hours apart but exist on completely different days. For example, over here, these guys can be working away busy on a Monday, and only a few hours away, everyone's still chilling over here on a Sunday. But that is exactly what happens for Tonga and America Samoa. Tonga and Samoa are in the same time zone but are split by the international date line. That means when it's 5 p.m. on a Monday in Tonga, it's only 5 p.m. on a Sunday in American Samoa. But they're just an hour-and-a-half flight away from each other, a mere 552 miles. Therefore, if I spent my entire Saturday on Tonga, I could then catch a plane at midnight and an hour-and-a-half later find myself in American Samoa at 1:30 a.m. on Saturday and have the whole day again. Technically, my entire day could last 48 hours, and that's just by crossing the international date line. Sorry, watermelon. Okay. Imagine. Oh no, I've sliced it.